We're looking at the screen. No one needs to be looking at me.
You just went back to the conversion, Miss Holder. You're back with the winged on a pickle, so. Oh, well. I understand. I appreciate it.
It was too
All
tempting.
right. Ma'am.
I was saying it was too tempting to turn off my camera.
I know. All right. Preview test. And as we can see, there is a question about determine the probability of the given opposite event. Opposite event means a complement. So what is the probability that 46% free throw shooter will miss her next free throw? Well, what's the complement of 46%? 0.54? That should be your answer. Now, that's one of those questions I put on there to make it real easy. So just wanted to let you know. And of course, that's the only one with the United States in front of it. Determine whether the following individual events are independent or dependent. Then find the probability of the combined event. Drawing 3 red cards in a row. Well, I believe Hubert went over one like this. It was the marbles. But let's talk about it. There we go. First of all, how many red cards are there in a deck of cards? Anybody?
26.
There's 26. And their total cards is 52. Now, do they have with or without replacement on this? It says the cards are not to be returned to the deck. So that's without what?
It's without replacement.
Exactly. I tell you what. Even though y'all don't talk, some of y'all must have listened this week. Or you're not going to give me credit and say you already knew it, but that's okay. Without replacement means dependent. If I spelled it right. And 26 over 52 times what? What's the next one?
25 over 51.
25 over 51. And the next one?
24 over 50.
24 over 50. Now, Mr. Justin, I know you want to be interactive, but remember, you don't go too far overboard. These winged on a pickle people, they may beat you up after class, so you may be chastised.
I'll be safe.
Okay.
They can't find me.
Okay, they can't find you. Okay, I don't know. The winged on a pickle is pretty strong. All right, so it says, let's look at what the directions say. Type as a simplified fraction, which I think is bogus because in probability you always go by decimals, and for some reason these people that write these questions want you to be all fractions. All right, so let's get our handy dandy calculator out. And I thought I already pulled up the calculator, and evidently I didn't, so I suck. And it'll take 15 minutes for that calculator to pull up. I don't know why it does. I think it's a conspiracy. All right, somebody multiply 26 by 25 by 24, and then multiply 52 by 51 by 50. Somebody give me the numerator first, please. Well, here we go. It did pull up decent. There we go. All right, 26, because you're not going to give me the answer, times 25 times 24. That's 15,600. over 52 times 51 times 50. 132600. 132600. Well, you could actually take out the zeros. I'm going to see if I could do this without having to use a calculator. And 156 divided by 2 is what? 78. 78 over 7. No, that's going to be 6, 6, 3. Somebody check my math on that.
What did you get?
Hold on, I'll show you. I got 78. Oh, I'm not finished yet.
Okay.
I just divided 156 by 2 and 1326 by 2. I was wanting y'all to check my math. I don't think you're going to get, let's see, you can't divide 2 into those. 3, you could divide 3. Yeah, 3 will go into them. So 3 will go into 78 2 times and 6. And 3 will go in there 2, 2, 1. 3 will not go in there. 2's only 13. 13 will go in there. 91. I think that's the answer. I may be wrong.
I got 2 over 17.
Okay, we'll go with that because I'm doing it all in my head. Let's do 2 over 17. Well, if I could ever get the dadgum test back. 2, that's a dependent, and let's go with Mr. Justin's 2 over 17. And good job, Mr. Justin. I appreciate you helping me, although you're not supposed to, because you're breaking the class code, you and Miss Holder. All right. Mr. Stewart, do you feel better this morning?
I do. I passed it though to my kid.
Well, good, good. I'm glad you feel better.
Thanks.
Class, we need to do intervention on Miss Stewart. All right. How is homework quizzes weighed? And that's the only one that equals 100%. If a student does not complete an assignment, they get a 0. In a certain lottery, 5 different numbers between 1 and 11 are drawn. These are the winning numbers. How many different selections are possible? Assume that the order is unimportant. Combination 11, combination 5. So let's take our handy dandy calculator and let's do 11 combination of 5. Clear and clear. 11 combination, that'd be math, probability, combination, 5, and that's the denominator, 462. Now let's see how they want the answer and if they're asking if it's a winner or not. Yeah, 462, that's all they're asking. And see, that's the question I don't like, because a lot of people think, well, you got to buy a ticket. Well, in this case, they're not asking you to buy a ticket. They're saying how many different selections are possible. I agree with that. Okay. I agree with that question where it says how many different selections are possible. That's a good question. Check answer. All right, next one. And that would be what? No way, no how. If you miss a question on a test and you believe it is correct, you should send several emails with the last one saying hello. A musician plans to perform 5 selections for a concert. He can choose from 9 different selections. How many ways can he arrange? So that'd be 9. I don't see anything with order, do y'all? A musician plans to perform 5 selections for a concert. If he can choose from 5 different selections, how many ways? Sounds like to me combination. 9 combination 5. Show you a trick I learned in the war. Second, enter, and I just type in 9 combination 5.
Isn't it
09.
a permutation though? Because he can arrange his music. The order doesn't matter, or it does matter.
Well, it doesn't. I mean, where does it say that he
Oh,
needs order?
I just thought that since it didn't say that it doesn't matter.
No, if it doesn't say, that means it's a combination.
Okay.
Now that's the way I've seen the homework. Now, I don't know. This one we'll see in just a minute. But if it doesn't say, it's assumed to be no order. And I don't see anywhere on this problem that it says order. Does anybody? I mean, I don't. Let's see. Now, I'm not saying that I'm wrong if it is wrong, but there is nothing on this problem that says order. And usually what I've seen in the homework, they usually say, or where did you get that information, Mr. Justin? Did you read that in the book or what?
No, it was the how many ways can he arrange it that made it sound like since he's arranging it and there's music, he can put one song first and then another song second.
All right,
but if he does it another way, he's arranging it differently.
We'll go with that. We'll go with I think that's a little vague.
Yeah.
I think it's a little vague. But we'll try your way first because I believe in my students and I believe in you, Mr. Justin. So let's go ahead and try it. Let's do 9 combination of 9 permutation of 5. 9 math permutation of 5. Now let me go ahead and say this. If this is correct, good. Thank you, Mr. Justin. But I don't like the question because it's very vague. And right. 15,120. I don't agree with that at all. Only if you're going to hang everything on a range, that's a very weak word for order.
Yeah,
I mean, y'all see what I'm saying?
Completely sure.
What?
I wasn't completely sure because it was pretty vague.
I don't agree with that question. Yeah, if they could have put a certain arrangement, a certain arrangement, that would be even more toward order. But just how many different ways can he arrange his program? Okay, it might be program. Program may be a word for order. But that's very weak. That's very weak. So make a note if you see this problem on your test, go with a permutation, even though I don't agree with it. Go for a permutation. Okay, thank you, Mr. Justin. A baseball manager has 10 players of the same ability. How many 9-player starting startups can he create? Now, this one is a little bit more pro permutation, I believe. 10 permutation of 9. So take your handy dandy calculator. I made some of these kind of easy. I think I need to go back and change it. So second entry. And let's go with 10 combination of 9. I'm getting there eventually. Second insert 10. Delete. Permutation of 9. 362, 8,800. It's not much more precise than the last question, but I just know that if you ever play baseball, there is a certain batting order. Okay, and that's the only thing that I turn to on this question. When you're talking about baseball, you're talking about different orders. So that's why I went with the permutation on this one. Little bit better than the last question. Okay, this is a calculator drill. So if you want to do it on the calculator, you can do it on the calculator. I mean, you have to do it on the calculator unless you're Rain Man. All right, so I'm going to put parenthesis, 16, math, probability, close parentheses, divided by, open parentheses, excuse me, 13, factorial, times 3 factorial, close parentheses, enter. 560. Should be 560 at the end. Yep. In a grade book, to find your grade after you've completed all your assignments, make sure you hit overall grade, which they've changed that now. It defaults to overall grade because so many students couldn't hit the overall grade button. Sad. So they defaulted it now that when you pull up your grade in your grade book, it automatically defaults to overall grade. Now to see your grade, you have to hit, to see how it's calculated, you have to hit show calculation. An experiment consists of drawing one card from a standard 52 deck. What is the probability of drawing a 3? So that'd be 4 over 52, which would be what, 1/3 or 1/13? Which one is it, 1/13? 1 over 13, I believe, isn't it? If you look at Hubert's overall grade one day, if you look at your overall grade one day, and it has decreased from several days ago, what has happened? A 0 has been put in for a missing test or missing homework. Evaluate the factorial. 5 factorial over 3 factorial. Handy dandy calculator. 5 math factorial divided by 3 factorial. Maybe I need to go back and edit this test. What do y'all think?
What do you mean edit it?
Make it harder. All right.
I don't know. I like my grade.
But yeah.
I get you to communicate then, don't I? Miss Holder, what'd you say?
Yeah, please don't do that.
Yeah, I think I'm going to because I want to piss y'all off. Find the probability of a given event. Choosing 6 numbers that match 6 randomly selected balls when the balls are numbered 1 through 35. I'm looking for order here. Is there any indication of order? I don't see it. So it looked like it'd be 35 combination of 6. But I don't know with those last 2 questions. I don't know. Let's see. 35 combination of 6. So that'd be 35 math combination of 6. And that should be Biggie BA number 1623 160. 1623 160. Now, I don't think they're asking for a winner. They're just saying the probability. Okay, see, there's that. I don't like that. I don't like this question because they're saying the probability. I guess they want a 1. I don't like this question. I don't like the way it's Well, first of all, I need to change it into a fraction. 1, and then delete. Let's see if it'll bring that down. And of course not. Just forget it. 1 divided by, I done forgot the number now. I suck. 1, 6, 23, 160. 1, 6, 23, 160. See, this question, there's no indication that you even bought a ticket. Heck, there's no indication. Do y'all see the word lottery in here anywhere? Anybody? I don't see it. So, yeah, I disagree with this question, even though I got it right. This one, it says, find the probability of the given event. Choosing 6 numbers that match 6 randomly selected balls when the balls are numbered 1 through 35. Now, I don't have a problem with the 162, 3, 160. I don't have a problem with that at all. I have a problem with the way the question is worded. 1, doesn't even say it's a lottery, and 2, it doesn't indicate whether you bought a ticket or not. It doesn't ask if you're winning. It doesn't ask if you're playing the lottery. Y'all see what I'm saying here, or am I barking up the wrong tree? And nobody's gonna say anything. Okay.
Kind of.
Kind of. Do you see anywhere that it says? I mean, what would you do? I mean,
I think I got this answer correct.
you did.
So,
all right. Well, I just don't want to mislead any of y'all. Some of these questions to me are a little bit vague and a little bit closed information. There's not enough information there to put the 1 there. I don't see the word winning. I don't see the word lottery. I don't see anything. It's just assuming that, okay, these students know that if you're doing 6 balls, 1 through 35, that it's a lottery, and it's assuming that you buy a ticket. That's a little bit too much coming from this question. Do y'all see what I'm saying now? I hope. I don't know. Maybe I'm just crazy. Maybe I just do. Maybe I drink too much for breakfast. I don't know. Maybe, I don't know. Next. Determine whether the following individual events are independent or dependent. Then find the probability of the combined event. Randomly selecting a 4-person committee. Committee combination. Committee combination. Unless it says something different. All right. So when you're picking bodies, can you go back and redo? No. So is this with or without replacement? Without. Okay. The probability of randomly selecting a 4-person committee consists of 11 women. How many is in the total group?
25.
Thank you. So 25 is your denominator, correct? Or not the denominator, but n. All right, your total. So what about, it says the randomly, so that would be 4-person committee entirely of women. Okay, now that changes things. All right, women. So that means I'm going to pick a woman out of how many? 4-person committee. So that would be woman, 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 woman. So we're going to draw this thing out. This looks like a multiplicative. I thought it was a combination at first. So here we go. We've got 11 men and 14 women. Therefore, 25 is equal to n. So our denominator is what? 25, Hubert. Now, why is it dependent? Because if I pick, a 4-person committee, that means the first 4 women. Can I pick, let's say that Jane is in the women. Can I pick Jane and then go back and pick Jane again? No. So it's without replacement. Should be. Hell with this test, I don't know. should be without replacement, which means it's dependent. And how many women are we going to pick?
4.
4.
4. And how many women are there? 14 out of 25. Then 13 out of what? 24.
24.
12 out of 23. And 11 out of what? Now, what do they want? They want a decimal. What do they want? Round to decimals. There. That's good. So that was already picked. Oh, I highlighted that. Sorry. All right. So somebody give me a decimal and round it to 4 places, please. Well, I better do it on the calculator because I don't want Mr. Justin to get beat up. So I will go ahead and do it. So 14 times 13 times 12 times 11. That's going to be 24,024. 25 times 24 times 23 times 22. 303,600. 24,024. Oops, sorry. 24,024 divided by second answer. I got 0.0791. What'd y'all get? Okay. Appreciate the interaction. 0.0791. Comprende? Let me put it up there again in case anybody needs it. There it is. Y'all settle down, please.
I was trying to give everyone else an opportunity to speak up.
I know you were. I appreciate it, Mr. Justin. I believe we're fighting a lost cause here. I think this class is destined to be winged on a pickle.
I think so.
My only class out of 6 classes. Y'all got something to be proud of. Y'all all gonna have a corner closet with a mop sink, you know, because people don't like you because you don't interact. All right, so next. What should a student do if something happens? Wait until after grade turn-in to say anything to the teacher. A baseball manager has 12 players of the same ability. Again, when you're talking about baseball, what's it called? Batting order. So somebody do this one for me. I don't feel like typing it in. 12 permutation 9. What do you get? Y'all don't have a mouse to do your punching with. It just it's a whole lot easier with your finger. 12 permutation 9.
I had 79,833 and 600.
79 million. Alpha.
Or 79 million. Yeah.
And you need to watch those Liquid Breakfast also, Mr. Justin. Next.
Still waking up.
I know. That's why people don't turn on their videos. If you have incomplete assignments and Hubert puts a 0 in, what does a 0 do? It decreases your dadgum grade. Oh, I didn't know that. There's our word, trifecta. When you see the word trifecta, that indicates what? I told y'all this in your notes. Trifecta. What does that
3.
indicate? The first what? Somebody said it.
3. First, second, third.
First, second, third, which indicates what? Order. Says it right there. if there are 8 entries, how many tickets must you purchase to guarantee a win? So there's 8 horses, or 8 cars, or 8 whatevers, and 8 permutation 3. Somebody give me 8 permutation 3, please.
336.
So if you buy 336 $1 tickets, you're guaranteed to win at least what? One time. Because you bought all the different and that's why the racetracks, if you get, especially if you go to a horse race, they'll ask you to buy a trifecta ticket, and you buy one for each one. So if you spend $1 on each ticket and you buy 336 tickets, you're guaranteed to win. Now, let me ask you a question, just see if y'all can think this through. Will each win be the same money on a horse race?
No,
Exactly. No. Why not?
because second and third place are less than first place.
Well, no, because each horse has different what?
Oh, they have different odds.
Of winning. So let me just put it to you this way. Let's say that Miss Holder, she goes and buys 336 tickets. All right, and she buys each one.
With whose money?
Say again, what?
With whose money?
We're living in fantasy land, Miss Holder, okay? All right. You know, where some people actually do live. She buys 336 tickets for $1 a piece. And let's say that the 3 dumbest, most stupid, most lazy horses come in first, second, and third. Is she going to win a lot of money? Yes. Because the odds against those 3 lazy horses winning are very, very high, the odds against. So the probability of those horses winning is very low. And when the horses are very low, the probability is very low, she's going to win a lot of money because she bet on all the horses, but she bet on those 3 losers being first, second, and third. Everybody see what I'm saying? Now, what if Mr. Justin goes and buys 336 tickets, and Secretariat, Seabiscuit, and some other horse that's won all 3 of them before come in first, second, and third? Is Mr. Justin going to win the same amount of money as Miss Holder? No, because Secretariat and Seabiscuit, they are descendant of those 2 horses, is a guaranteed win. So Miss Holder would win more money at the race that she's at with the 3 losers coming in first, second, and third, where Mr. Justin will win less because Seabiscuit and Secretariat and I don't know another horse, but another horse has won a lot of horse races. That is almost a given. Okay, I'll shut up. Check answer. Y'all settle down, please. Why does Hubert not entertain extra points, dropping any grades, or extra credit at the end of the semester? I kind of like alpha, but it's delta. Suppose that an urn contains, oh my gosh, look at this, marbles. 2 black marbles, 2 white marbles, and 8 green marbles. If one marble is selected, determine the probability that it is white. And what would that be? 10 over what?
20, which is 1/2.
Which is 1/2. Thank you. And it says, well, maybe I need to take that one off the test. That's just too easy. I need to take that one off. Next. Answer the following question using arrangements with repetition, permutations, or combinations. Be sure to explain why the particular counting technique applies to the problem. How many different 6-character passwords can be formed from the uppercase letter A through F repetition is not allowed. So A to F. What would we do here? Well, how many you got? How many? 6 characters. I'm just going to draw this out because we got to think this through. You got 6 characters. 1, 2, 3, 4, 5, 6. Well, it says that we can use letters from A to what? It says we can use letters from A to F, Hubert. That's right, class. Thank you. A, B, C, D, E, F. Now, once we use A, we can't use A again. So we drop down from 1, 2, 3, 4, 5, 6. We drop down 6 to what? 5. And then we drop down 5 to 4. So what does that seem like? If we drop from 5 to 4 to 3 to 2 to 1, what does that seem like? I'm asking y'all to interact if y'all haven't caught on to that Q, which QUE means. I'm trying to get you to say something.
It just keeps decreasing over time, like as soon as you go down.
No, which one of our counting methods goes 5, 4, 3, 2, 1?
Permutation.
Not permutation, but what makes up the permutation? Starts with an F. A, C.
Factorial.
Factorial. Probably. I would suggest that mainly. That's what I would do. I would do maybe 6 factorial. Now, I may be wrong. I may be reading this question wrong. 6 times 5 times 4 times 3 times 2 times 1. 6 times 5 is 30. 30 times 4 is 120. Y'all check me now. 120 times 3 is 360. 720. I would say there's 720 different combinations. Okay. Let's see. I don't know. Maybe arrangements with repetition should be used. No item may be selected more than once, and the order matters. Arrangements with repetition. It's not with. It says without repetition. So Charlie and Delta is out. Because we make selections from a group of choices. No item may be selected more than once, and order matters. Does it say order matters up here? I don't see it.
I don't see
So
it.
I guess it would be combination. I don't like this question. I thought it would be 720, but I'm not sure now. Yeah, 50% right. So I have no idea if I got. Evidently, I got the answer right. I just don't know what the hell they're talking about. Because you read the daggum. I hate when they start writing. Well, evidently, it's a permutation there. Now, that's not a permutation when you use factorial. I don't like this part. Write this down. Permutation should be used because no item can be selected more than once and order matters. But what I just did here, that is not a permutation. That is a factorial. So I don't like. I like the question asking for that, but I don't like that because you're not really using a permutation. But write it down so you won't make the same mistake I did.
Well, the answer is still 720 with the permutation. So like,
It is.
Yeah.
Okay. Well, then I just did it. That's just one of those that you can do either way. Okay, so permutation. Write down permutation then. I didn't know he gave you the same answer. So what did you do? 6?
I just did 6 permutation 6.
Okay. So you can get the same answer either way. I didn't know you could get the same answer both ways. Next. Okay, in a certain town, 5% of the people commute to work by bicycle. If a person is selected is randomly from the town, what are the odds against? Well, let's go to the handy dandy whiteboard because I have no idea. I'm going to go ahead and write down odds against to remind you. Odds against is equal to the probability of failure over the probability of success. Okay, so picking a person riding a bicycle, the probability of picking a person riding a bicycle, I don't know how to spell bicycle, I guess it's like that, is success. Okay, so what is 5%? How else can you write 5%?
1/20th?
5 over what? And yeah,
5 over 100.
5 over 100. And you say that goes down to what, Mr. Justin? 1 over what? 20. So the probability of success is 1 over 20. So that goes on the bottom. And what's the complement of 1 over 20?
19 over 20.
Thank you so much. And leave it as a fraction so it's easy to calculate. When you divide a fraction by a fraction, you multiply by the what? And you're left with 19 to 1. Delta. In a certain lottery, 5 numbers between 1 and 12, 12 and 5 are drawn at random. If you choose 5 different numbers at random between 1 and 12, what is the probability that you will match the winning numbers? Assume that the order is not important. So that's going to be 1 over 12 combination 5. So somebody do that for me. Do 12 combination 5, please. Hello? I'll do it myself.
I was getting my calculator out.
Thank you. 12 combination 5. What is it?
I got 792.
That would be delta. Next, answer the following question using arrangements with repetition. All right, how many different rearrangements? It doesn't have to mean anything. Here we go, 6 factorial, that'd be 720. All right, whenever you got if they give you, I'll give you another example. Let's go with Miss Gill because she's got a short name. All right, so we're going to go with Miss Gill. G-I-L. How many different arrangements of these 3 letters can I have? Well, that's going to be 3 factorial. 3 factorial is 3 times 2 times 1, which is 6. So G-I-L, G-L-E, or G-L-I, then I-G-L, and then I-L-G, and then L-I-G, and L-G-I. Okay, so what would be this one? 6 factorial, which we already said is 720, right?
Yes.
I hope you didn't mind me using your name, Miss Gill, but you got a short name. That's why I used it.
No, it's
I
fine.
hope you're not offended. I hope not.
No, I'm
If
not
you take
offended.
several forms of a test in Hubert's class, how is it counted? Takes the highest grade. You are dealt 2 cards successfully with replacement of the first. Okay. If you are dealt 2 cards successfully with replacement of the first from a 52 card deck, find the probability of getting a heart on the first card and a diamond on the second card. And so you know you're dealing with what law here? And the replacement. What are you dealing with? The additive or multiplicative?
Multiplicative.
Good job. So how many, let's see, what do they ask for first? How many hearts are there in a deck of cards?
13.
There's 13. So they asked for a heart, excuse me. So they asked for a heart, 13 over 52. And then they put the card back and then a diamond on the second. So how many diamonds are there?
13.
So it's 13 over 52 squared. So you could just, this is 1/4 times 1/4. And 1/4 times 1/4 is what? Thank you, class. 1/16. Thank you, class. Thank you, whoever said that. Thank you. A bag contains.
I'm sorry.
I'm sorry, what?
I said 1/8 because I was adding. My bad.
Okay, well, we all know, yeah. Thank you, Miss Gill. We feel sorry for you, but that's okay. All right, a bag contains 13 balls, 1 through 13. What is the probability that a randomly selected ball has an even number? A bag contains 13 balls. Okay, well, let's go to our handy dandy whiteboard here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And take our handy dandy highlighter out and highlight. Now there's an easier way to do this, and I'm going to show you, but 4, 6, 8, 10, and 12. 1, 2, 3, 5, 6. Usually you can take the number and divide it in half, and that would be 12 divided by 2 is 6. And I just thought you'd want to know that. But anyway, it's usually half. So how many are odd? Well, 13 divided by 2 is usually 6. 1, 2, 3, 4, 5, 6, 7. Sorry, 7. Because 7 and 6 is 13. But anyway, 6. 1, 2, 3, 4, 5, 6. So 6 out of what? 13. And what is that? A, alpha? Decide the method, theoretical, relative frequency, or subjective is appropriate and compute the estimate for the probability. An experiment consists of drawing 1 card from a standard 52 card deck. What is the probability of drawing a black face card? All right, so do you have a deck of cards in front of you? Miss Holder, you're in your closet, so do you have a deck of cards in front of you?
That would be a no.
Okay, so that means it's not relative because she's not observing it. Do you feel, okay, Miss Holder, do you feel that you know the answer? Do you feel it in your heart? No. All right? That's just subjective, so take that out of the question. So what's the only thing left? Theoretical. So how many black face cards are there in a deck of cards? Well, I go to my handy dandy. Where did I put that thing? There it is. I go to my handy dandy index card that Hubert told me to do. And I go to my deck of cards here. And I look for black face cards. How many black face cards are there?
6.
Good job. So 6 black face cards out of what? 52? And that is some number. What is it? It says type as a simplified fraction. So that's going to be 3 over what? 26? I don't know what that can be, but I'm just going to put 3 over 26. You are dealt 2 cards successfully without replacement. We already did this one, but let's see. First card is a king. Second card is a queen. So that's going to be 4 over 52. 4 over 52 is the same thing. What is it? 4 over 52, that's 1/13. So it'd be 2 of 13. I'm sorry, I had a brain bubble there for a second. No, I did.
How many more questions are we going to be going over?
Well, is it time for class to be over?
It's
I'm
10:03.
Okay, well, y'all get an idea of what kind of questions are on the test now, right? Okay, when's the test due?
I thought it was due on Wednesday.
It's due
Yeah, I
Monday.
thought it was due
You're
at
welcome.
midnight.
They're due Monday, so you're welcome.
Oh.
Thank you, Hubert. Y'all have a good weekend.
Thank you, you too. Have a good
All right,
day.
see y'all.
Hey, Mr. Hubert. Mr. Hubert.
Yes.
Can I
Yes.
talk to you after class?
No. Yeah, go ahead.